All right, so we're now moving on to lesson 9 from unit 1 on scale drawings. This one we're looking at creating scale drawings. So the biggest part is knowing what is our scale that we should use, or what's appropriate scale to use. To start off, number talks which is greater. So just without calculating which one is greater, well, when I look at these, I say, well, 11 times 2 is 22, which is less than 23, so this is going to be less than half. The next one, 7 times 2 is going to be 14, which is larger than 13, so I know 7 divided by 13 is going to be greater than half. So this one would have to be the larger number. Next one down, now if you're taking a larger number and you're dividing by 2, that's always going to be greater than a smaller number divided by a bigger divisor. So 0.63 divided by 2 is going to be the larger number. Same thing kind of falls down here. If you take 15 and you divide it into 3 groups, you're going to have more people per group than if you take 15 and divide it into 4 groups. Fewer groups means you can put more in there. All right, there is an interactive on the link in Google Classroom for this. If you're probably watching this video, there's a good chance this is the one you probably referred to for this next section. So it says the actual length of a wall C is 4 meters. To represent wall C, Noah draws a segment of 16 centimeters long. Excuse me, it says, what scale is he using? Explain or show your reasoning. Well, he's going 16 centimeters is equal to 4 meters. Well, if we were to find out what 1 centimeter is, you would say, well, you'd have to divide both sides by 16. So that would tell you that 1 centimeter is equal to 1/4 of a meter. Okay, so that would be the expression there. But once again, you have a fraction here. So to make it a little easier, let's try and figure out what we can multiply the fraction by so that it's a whole number. So, well, you have to have 4/4 to make a whole, so we're going to multiply both these by 4. So this would be 4 centimeters is equal to 1 meter. Okay, this is all the same. Okay, this is a different way of writing that, and it's something that more people will probably be more comfortable using rather than dealing with a fraction. All right. And you might find a different scale that you prefer, but this roughly right here is the scale that I'd feel is in the simplest form. Okay, so it says the actual length of wall A and wall D are 2.5 and 3.75 meters. Determine how long these walls will be on Noah's scale floor plan. Explain or show your reasoning. Okay, so you can either say, well, for each meter there's 4 centimeters. So A and D is going to equal 2.5 times 4, which is going to be 4 times 2, which is 8, and then 4 times 0.5, which would be another 2, so that would be 10 centimeters. And D is equal to A. For the, let's see, what was the other wall? And 3.75 meters. Oh, never mind. I read that wrong. Yeah, so then D is equal to 3.75 meters times 4. So 4 times 3 is 12. And then 0.75 of 4 is another 3. So 12 plus 3 is 15 centimeters. So those would be the actual dimensions. Okay, so now on the interactive, it actually wants you to draw this out. Okay, so it gives us wall C. It wants wall D is 3.75, so that's going to be a total of 15. So we're going to go up here to 15. And then it says wall A was 10. So we're going to go up here to 10. And that would be the scale drawing of those two walls. Okay. So let's go back. And for those who have the paper copy, you're just going to draw that in centimeters. There should be enough room on your paper copy. All right. It says, are you ready for more? If Noah wanted to draw another floor plan on which wall C was 20 centimeters, would 1 centimeter to 5 meters be the right scale to use? Explain your reasoning. At first look, you might think, well, 4 times 4 was 16, so 4 times 5 is 20, and say this is correct. However, this scale is backwards. Remember, it was 16 centimeters to 4 meters. So now, if instead of 16 we did 20 centimeters, that would just mean 20 centimeters is equal to 4 meters, right? Because the original length of that wall C was 4 meters. All we did was change the 16 to 20. Now, if you want to get this down to just a single centimeter, you'd have to divide both by 20. Here you get 1 centimeter, and that would be equal or is equivalent to 1/5 of a meter. Or you'd multiply both by 5 and say 5 centimeters is equal to 1 meter. So note that's why this is not correct. You'd have to switch it around. 5 centimeters is equal to 1 meter. Okay, it says 2 maps of Utah. A rectangle around Utah is about 270 miles wide and about 350 miles tall. Okay, the upper right corner that is missing is about 110 miles wide and about 70 miles tall. Make a scale drawing of Utah where 1 centimeter represents 50 miles. In this, you're just going to want to draw this out in your notebook. Okay, unless you have a printed copy, then you can draw it right here on the printed copy. All right, so it tells us that 1 centimeter represents 50 miles. So, to find how many centimeters we need, we're going to have to divide the actual distance by 50, and that'll tell us how many centimeters to draw. So, let's see, the width on the bottom is 270. We're going to divide that by 50. So 50 can go into 27. It can't, but it can go into 270. So really what we're looking at is how many times can 5 go into 27. And we know 5 times 5 is 25. That would be 250. And then when you minus that, you're left with 20. You're going to bring down another 0. And 50 can go into 200. That would be 4 times. Have to bring down the decimal when we extend the number that are in our fractions. So 5.4 centimeters according to this scale. So if you take your ruler, and once again this, I'm just using a ruler on my screen, so it's going to be so there's my 5.4 centimeters, which is equivalent to 270 miles. Okay. likewise for our height, we're going to do the same thing. 350 divided by 50, which is the same pretty much as 35 divided by 5, which is 7. So then this is going to be 7 centimeters. I'm not giving myself enough room here, but that works. So that would be the top. Okay, now it tells us that the corner that is missing is about 110 miles wide. So we have to take away 110 miles from 270. That's going to leave us with, so 270 minus 110. That's going to equal 160, or 16. When we divide 16 by 5, you're going to get 2 point. No, sorry, not 2.3 point. Be 15, 1, 10, that'd be 2. So 3.2 centimeters is how far you're going to go across. So now on the top, 3.2. Okay, and then it says the height is about 70 miles tall. So take 350 minus 70. That's going to leave us with 280. Right, well, we know that when we divide it by 280, we got 5.4. This is just going to be 20 more, so that would be, sorry, that'd be 10 more, which is going to make it 5.6. So then height here, whoops. Yeah, okay, yeah. Just had to think about that for a second. Okay, so then draw the line up. Then we can make the connections. Now you've got Utah on that scale that it's talking about. So once again, this was 7 centimeters, where the actual length was 350 miles. This one was 5.6. Oops, here, I'll keep it on the outside. 5.6 centimeters, where the actual length was 280. And then the actual length was 160 miles. And that was, I think, 3.2 centimeters was the height, or was the width. So if you want to know these dimensions here, you could just draw straight lines to connect them. If you wanted to figure out what this length should be here, you just take 5.4 minus 3.2. And when you do that, you get 2.2 centimeters. And that should correlate to 110 miles. And then likewise here, that's going to be 7 minus 5.6, which is going to leave you with 1.4 centimeters, which is equal to 70 miles. Okay, it says make a scale drawing of Utah where 1 centimeter represents 75 miles. So we're going to do the same thing. You're just dividing here. But now you're dividing by a bigger number. And so 75 can go into, let's see, 270. then 75 can go into 350. So when you divide that, let's see, 75 and 75 is 150 plus another 75. So that would be 375. So 3 times 75 is 5. Carry the 1. 3, 2, 10, 22. That's going to leave you with nope, not 50. 6, that'd be 45. So that'd be 450. And then 75 can do that 6 times. So now the bottom of Utah is going to be 3.6. That might have been a little bit. No, that's right. Okay, and then the top is going to be, so this could be 4 times. That'd be 300. That'd be 0.6. It'd be 450. So it's just going to be 6 repeating. So 4.4 and 2/3. On the scale I'm given, I'm just going to go 2/3 is right at 4.7, or kind of in between 4.6 and 4.7. Okay. Okay, now we're going to do the same thing. We're going to take, for the length, it's 270 minus 110. Or actually, I guess we still can use these numbers over here. 280, so 280, 280 divided by, not 70, 75. So that'd still be 225, which would be 3. And then that's going to leave us with 55. And then that can go into 557 times. Which would be 525. I think that's with 250. And we already know 250, well, yeah, that's going to be 3. So on the scale drawing, I'm going to go right, pretty close to 3.7. Okay, and now I know that that's only going to be 110 over, so I'm just going to, 75 can go into that. Excuse me. 110, 75, that's going to be once. That's 75, and when you subtract that, that's going to give you 35. So you're going to bring down, or 0, so 350. You know, that's going to go in at least 4 times. I think that's a 300. And then we're going to be 6 repeating. So this one's going to be close to about 1.5 centimeters. Okay, and then 70. Well, 70 is just shy of 1. So in between 9.9 and 1 centimeter. And then you can connect the tops. And so there's the second scale. So obviously you notice that the first one that we did was much bigger, but the scale we used represent 1 centimeter represent a smaller number of miles, where on the second one, the 1 centimeter represents a larger number of miles. So this is a shrunken down version. The second one right here is a shrunken down version. So obviously the more miles or the more measurement that one unit represents on a scale, it's going to shrink the size of the original down even further. Okay, last thing, there's summary. There's a little more on Google Classroom about summary, but just to make sure we've got the right idea here, it says drawing a pool. A rectangle swimming pool measures 50 meters in length and 25 meters in width. Make a scale drawing of the swimming pool where 1 centimeter represents 5 meters. So 50 divided by 5 is going to equal 10 centimeters. And 25 divided by 5 is going to equal 5 centimeters. So when we draw this out, you're just going to use your ruler, go 10 centimeters, and then go 5 centimeters wide or tall. Now I'm going to cheat. Oops. That's the wrong thing. I'm going to cheat and move this down just a little bit. Okay, and then we can do the same thing on the top. It tells it's a rectangle, so we know that the sides should all be the same in length. And as you can see, that's a little crooked, but that wasn't even close. That line's not straight, but there you have it. Now it says, what are the lengths and widths of your scale drawing? So we found that up here. This is 10 centimeters, and this is 5 centimeters. And that's how you can find scale drawings or use scales to change your drawing size. So once again, remember if it's for 1 centimeter or for 1 unit, as long as the number that represents gets bigger, your scale